Right, Ante-Matric, this is a walkthrough of your recent test that you wrote. So the idea is that you can go through this and check your answers, check the working out, and if there are any questions, you can then check with your own teacher for any further clarification. For question 1, the cumulative frequency curve below shows the heights of a sample of 50 randomly selected females between the ages of 20 and 29. So on the y-axis, we have the cumulative frequency, that's the count of how many girls, and on the x-axis, we have their height in inches. All right, so the total of 50 does correspond to the highest cumulative amount. Question A, what percentage of women are shorter than 62 inches? So we're going to look at the 62 on the x-axis and read up on the y-axis what the equivalent is, and we get an exact answer of 5. Right, so 5 people out of 50 is 10%, but the question's a little tricky because it asks for women that are shorter than 62 inches, not 62 inches and shorter. So that means that the 10% includes those who might be exactly 62 inches. So our answer then needs to be less than 10%. If you said 10%, we would still accept it as a Section A question, but just bear that in mind. Question B, determine the number of women taller than 68 inches. Right, so 68 inches over here, and if we look at the corresponding value there, I would say that that's around 36 on the y-axis, which leaves us 14 people between 36 and 50. So 14 people would be taller than 68 inches. Question C, write down the median height of the sample. So we know that the median is at around 25 or 25 and a half. So from 25, we go to the graph and read off the corresponding x value on the x-axis, and we get 66 inches. Question D, estimate the interquartile range of the sample heights. Now remember, it's saying estimate because we can't read it off exactly. We're estimating as best as possible on the graph that they've given us. We haven't got actual figures. So we know that the interquartile range is quartile 3 minus quartile 1. So back to the graph we go. I'll use green this time. So our first quartile is halfway between 0 and 25, so we're at around 12 and a half. So 12 and a half, and then we read off on the x-axis, so that we get a quartile 1 of 64. For quartile 3, it's halfway between 25 and 50, which is 37 and a half. So 37 and a half round about here, read across to the graph and down to the x-axis, and we get 68 or 69. We'd accept both of those. So that means we've got 69 minus 64, which is an interquartile range of 5 inches. For question 2, the first part is just to populate your graph, your table properly. So our values are going to be 2, then we're going to have 4. Remember, that's adding these 2 to get the 4, and then we're going to add the 1 to get the 5, and so on. So we get 11, 37, 50 is there to check that we're on the right track, 70, 101, 130, and 166 for the last one. Right, then the points to plot. Remember, the points to plot are always your end point of your interval and the cumulative frequency. Those two values together, in that order, make up your coordinates that you have to plot. So we're going to have 8 and 2. We're going to have 8 and a half and 4, 9 and 5, and so on. Right, looking at the questions, calculate the value of A and B. Well, let's look where A is. A would be a value that needs to be added to 37. So 37 plus a must equal 50, because 5 plus 6 is 11, and 11 plus 26 is 37. So 37 plus what will give us 50? It is 13. And then b, same thing that we're looking at down here. 101 plus b will give us 130. So therefore b is 29. For question B, complete the table and on the grid below, draw a cumulative frequency graph to represent the given data. So you now need to plot all those points so that it looks something like this. Remember, 1 or 2 points, it needs to be drawn freehand. Secondly, this point must be grounded. That is very important with the cumulative frequency curve. Question C1. You have to, on the graph, indicate where you would read off the following and record your results below. First of all, the median. So that is exactly halfway in the 166 competitors. So half of 166 is 83. Right, so at 83 or thereabout, we're going to go across to the graph. And we read our way down to the x-axis. And this is where you need to mark off where you read your value. So I would say that that is around 11.3, and we do give you a little bit of leeway either side. Then for the lower quartile, we're looking at around 41.5. Excuse my line. So we go across to the graph, and we read down to the x-axis, and I'd say that that is at around 10.2. Right, for the upper quartile, we're looking at around 124.5. So we go from the y-axis all the way to the graph, and then read down on the x-axis, and I'd say that's around 11.8. All right, and mark that where you've read that off is quartile 3. The important thing is that this is where you read it off. You don't read it off here. You don't read the values there, and you don't read the values there. These values give you the position of the quartiles and the median, etc. The x values give you their actual values. Question 3a. For the mean, you need to add up all the values in the table, all 9 values, and divide by 9. So we get 4,281 divided by 9, which gives us, and remember they asked for correct to the nearest 1,000, so that gives us 476,000 once we round off. So you can either write it like that, or you can write 476,000. Right, then the standard deviation of the numbers listed in the table, also correct to the nearest 1,000. So our symbol for standard deviation is the sigma from Greek. So in order to do this on your calculator, I'm just going to help you with the steps quickly. You press Shift 3 to get to stats mode. I'm working with a silver calculator. And in your table, under X, you input all those 9 values, the 1,500, 1,100, and so on. When you get to the bottom one, you press equals, and you press AC. Then you press Shift 1, and you go to menu 4, which is variance, VAR. Press 4. And you're then looking for 3, which is your standard deviation. So in this case, the standard deviation is 4, and you press equals. The standard deviation is 494,8 thousand. So you want to round that up to the nearest 1,000, which is then 495,000. For question C, what percentage of the given numbers lies within one standard deviation from the mean? We first have to work out what the interval is of the standard deviation. So what we would do is we say, well, the mean is 476. So if we subtract 495,000 from 476,000, we get a lower bound of negative 19. And then if we add the 495,000 to 476,000, we get a value of 971,000. So remember, these values that I'm writing now are in thousands. Okay, so to work out the percentage then, we have to work out what is the difference between those values. Not the difference, sorry, but the amount of tourism sites that fall within that standard deviation. So obviously from negative 19 to 0, there's none of those. But all the values from 9, 8, 7, 6, 5, 4, 3 are all within that standard deviation from the mean. So that is 7 out of the 9. So therefore, we'd say 7 out of 9 times 100, which gives us to 2 decimal places, 2 0 decimal places, 78%. And to 2 decimal places, it is in fact 77.78%. Question D, the next tourist site on the list was the Apartheid Museum. If this 10th site is added to the list, the mean becomes 433,2 thousand. Calculate the number of thousand visitors to the Apartheid Museum. Right, so we already know that the previous mean was 4,281. Well, sorry, the total was 4,281. Now we've got another site, which we're going to let equal x. And if we had to work out that mean, we would divide that by 10, because now there are 10 sites in total. And they've given us the mean. Remember, we're working in thousands now. So 433,2 thousand is the same as 433,200. All right. So now we're going to multiply both sides by 10 to get the variable, to start getting the variable on its own. So we get 4,332, and then subtract the 4,281 from the 4,332 to get 81,000. Okay, section B, question 4. This is the scatter plot. I'm going to go straight to the diagram. And we're going to draw the scatter plot to represent the information given. Right, so that is what your scatter plot should look like. No need to label those points. You just need to put the coordinates there. Okay, remember that this symbol here means that there's a gap between 0 and 25, and it's not to scale. Right, B, determine the equation of the regression line. Remember, it's in the format y hat equals a plus bx. Right, so onto your calculator you go, and you need the values of a and you need the values of b, and you get y hat equals, a is a negative 21,5, and b is 0,96. Right, so that's your equation of regression. Right, for question C, draw a clearly labeled regression line on your graph. Now, because we can't really see exactly what the y-intercept should be because of that gap in the graph. Okay, if I go back to the graph here, because of this gap, what looks like the y-intercept won't be the actual y-intercept. So we can't just say that negative 21.5 will be, we can't plot the negative 21.5 here. All right, so what we need to do is we pick one other point. So let's take when x is 25 degrees, and the idea is you substitute, when x is 25 degrees, substitute that into your equation of regression. And you get a y value of 2.5. Right, then we need one other point. So, on your calculator, if you press Shift 1 and then go to 4, the variance menu, you'll then see that you've got options 2 is the mean x, and options 5 is the mean y. That gives you your other point, or your mean coordinate. So the x value is 29.5, and the y value is 6,9. Now with these 2 points, you then plot those and then sketch your regression line. So now if I plot those 2 points, which was 25 and 2.5, so 2.5 and 25 would be there, 25x, 2.5y, and then the mean point was 29.5 and 6,9. So 29.5 and 6,9 is around there. Let's make it a little bit higher. And those 2 points we then link. And there is our line of regression. Okay, question D. Predict the number of flowers if the temperature is 52 degrees Celsius. So we would substitute into our equation the 52 as the temperature, the x. So 21.5 plus 0.96 times 52. And we get around 28 or 29 flowers, depending on how you rounded it off. And we need to make the conclusion that that is not valid because it is extrapolation. The 52 degrees does not appear on the graph. And also, logically, the more hotter it is, we can't have that many flowers. For question E, determine the correlation coefficient for this data and comment on the strength of the correlation. So you would need to go, hopefully your data is still stored in your table. You would say shift 1 again. Then option 5 for regression, and then option 3 for R, your correlation coefficient, and press equals. And in this case, you get that R is equal to 0.83. And this would be a fairly strong positive correlation. All right, remember that your R value is between -1 and +1. The closer to 0 would mean that there's less of a correlation, and the closer to -1 would be a strong negative correlation, and the closer to +1 would be a strong positive correlation. So 0.83 is closer to 1 than it is to a half, so, which makes it fairly strong, and it's positive because it's greater than 0. Okay, question 5. The given data values reflect the masses in kilograms of 20 athletes in the school team. The important thing to realize here is that there are an even number of masses, so therefore your median is going to be in between two of the values. All right, so question A, determine the value of X if the median of the data is 61.5 kilograms. So the median actually needs to be this value X and that value added divided by 2, because the median would lie in between those 2 points. So therefore X plus 63 divided by 2 is equal to 61.5. They've given us that. And then solve for X by multiplying both sides by 2. And then you take over the 63 so that X is equal to 60 as your median. Right, the interquartile range. Quartile 1 would be in between 55 and 57. And quartile 3 would be in between 66 and 67. So those two values then for the interquartile range, we would say quartile 3 minus quartile 1, so 66.5 minus quartile 1, which is 56, and that gives us an interquartile range of 10.5 kilograms. Question C, a value in the data set is considered to be an outlier if that value is either less than quartile 1 minus 1.5 times the interquartile range, or greater than quartile 3 plus 1.5 times the interquartile range. So determine whether 40 kilograms is an outlier of this data set. Now, obviously, because of the size of this mass, 40 kilograms, it'll be closer to the smaller side of the set. So we only have to use this part of the equation. We don't have to use that part of the equation. All right, so let's calculate that. And they're asking us to say that quartile 1, which we've already worked out in the question above, is 56. So using this formula, we're going to say 56 minus 1.5 times the interquartile range, and that gives us 40.25. So the value that we're looking for, 40, is less than quartile 1 minus 1.5 times the interquartile range, and therefore, because it's less than 40, because 40 is less than 40.25, it means that 40 kgs is an outlier. Right, question D. If 4 kilograms were added to each data value in the given set, what effect would it have on the resulting mean? Firstly, the mean would also increase by 4 kilograms. because if every single item is increased by 4, then it means the whole average increases by 4 kilograms as well. And question 2, the standard deviation would remain the same because although every data value has been increased by 4 kilograms, their spacing from each other still remains the same. So that's why the standard deviation remains the same. Okay, question 6, a problem-solving question because it involves something that you haven't seen before. But really, essentially, all you need is this. And you need to work out the mean, the median, and the standard deviation. So we've discussed in previous questions how to work out those values. So I'm not going to do that now, but let's just write them down. The mean of this data set. And again, you can type these into your calculator, into the stats function, and work out the mean from that directly. But the mean is 27,14. The median is 26. And the standard deviation is 2,03. So our formula then needs to be 3 into the mean, 27,14, minus the median of 26, all over the standard deviation of 2,03, which gives us a total of 1,68. So we now take that 1,68 and we look, where is it here? It says if the index is greater than 1, then it is skewed to the right. So 1,68 is greater than 1, therefore the data is skewed to the right.